Welcome to our chapter, Case Study MEFID Solar Link. In this video we show a hypothetical and exemplary case study of 4 dispatchable solar power plants in North Africa, each with a separate transmission infrastructure to 4 regions in Western Europe. This example focuses on an evaluation of technologic and economic data giving a first picture of the infrastructure. Hereby we consider the local infrastructure in North Africa with an exemplary water pipeline providing the possibility of local agro-forestry. Nevertheless, a specific and detailed feasibility study is essential, identifying and concretizing chances and challenges which could lead to a breakthrough of a potential implementation.
In this schematic picture we show the example of MEFID Solar Link, which regards Morocco as dispatchable solar power plant hotspot and 4 energy-intensive off-taker regions in Western Europe, the 4 motors for Europe, by name, Baden-Württemberg, Lombardia, Rhône-Alpes and Catalunya. Thus, the name MEFID consists of Morocco, España, France, Italia and Deutschland. Each of the colored regions has a separate transmission line to an assigned power plant. This enables the indispensable and independent technical control of the power plant inside an off-taker region even when the power plant is thousands of kilometers away. The essential idea of this separate but common infrastructure is to bundle separate transmission lines in corridors to accelerate implementation time, reducing service and maintenance and keeping the power supply infrastructure independent. In this variant high-voltage direct current, HVDC, lines with 600 kV are used as underground and sea cable version. The dispatchable solar power plants are based in the Moroccan regions Oriental and Meknès-Tafelalet. Dispatchable solar power can be generated in North Africa all year, while in Southern Europe the yield drops drastically in winter due to rotation of the Earth's axis. A common infrastructure also is implemented inside Morocco, providing sustainable water from sea water desalination at the Mediterranean coast and transporting the resulting freshwater to the area of the power plants. This freshwater would be used for agroforestry and for maintenance of the power plants. New living area and job possibilities, about 1 job per megawatt for the power plant alone, can therefore be created in a multilateral win-win environment for all involved participants.
In the present table, an approximation of the dimension and cost of dispatchable solar power plants for the example of the 4 motors for Europe are made. The analysis is based on cost of the year 2015, therefore not inflation adjusted, the learning curve of concentrating solar power, CSP, and HVDC cost assumptions. To save expenses, a combination of CSP and photovoltaics, PV, inside a power plant is useful to cover the electrical demand of mirror tracking pumps with about 13.5% PV of total capacity instead of using CSP solely. The water demand of the 4 CSP power plant parks is about 17 million cubic meter per year for mirror cleaning, supplying workers, and using a dry cooling. An additional demand of 20 million cubic meter per year is assumed for agricultural use around the power plants. The cost and dimension of water desalination and water pipeline are approximately 10% of the dispatchable solar power plant, leading to a water price of around €1.8 per cubic meter. The total investment cost of dispatchable solar power plant including transmission line and water infrastructure is between €9,600 and €11,330 per kilowatt net, assuming the same net capacity of 1.5 gigawatt and annual net power supply of 10.6 terawatt-hours of each of the 4 motors for Europe. Levelized cost of electricity, LCOE, are about 12 to 13 eurocent per kilowatt-hour. Total investment can still drop with a decreasing learning curve of CSP if this technology is further implemented. LCOE strongly depend on interest, discount rate and amortization time. Interest can be reduced by guarantees leading to a higher credit rating.
Regarding the rising energy demand of mega cities, communities worldwide might be a suitable off-taker of renewable dispatchable energy from distance to cover their energy needs. The entrepreneurial risk of a dispatchable solar power plant, including the transmission infrastructure with an investment of around €10,000 per kilowatt, should not be underestimated. Thus, it would be an option to disperse the risk among many by simultaneously guaranteeing their energy provision. With the right framework made from legislative institutions with guarantees, power purchase agreement and no direct financial subsidies, is conceivable that a mixture of investors from all parts of society can manage such a potential project in a participatory enterprise like in many present local initiatives for renewable energies.
Only a specific and detailed feasibility study can lead to a breakthrough regarding geographical, technical and financial impact, as well as political and framework assessment. This is especially needed regarding all technological options of sustainable energy supply, including dispatchable solar power, its transmission from desert regions and its value for the energy system as one major supplemental component, providing flexible supply according to demand at any time with firm capacity and firm energy. Now it can be Umina showing the world that it is still possible to cooperate and to build up trust at eye level in a multinational and multicultural environment. An American wisdom says, "It takes at least two to tango." Feel free to follow and contact us via social media or email.